All right, so the first question is just your binomial coefficient. Obviously, we use these within the expansion, but then you're going to see when we get into the next two sections, there's other application of that C formula. This is your n factorial over n minus r, sorry, factorial times r factorial. So this would be 8 factorial over 8 minus 3, which is 5 factorial times 3 factorial. I'm going to break down the 8 until I hit the 5 factorial, line those up, and then break down the 3. Then I can cancel through the 5 factorials. 2 goes into 6 3 times, and then the 3's cancel, and you get just 56. So again, there's going to be 2 uses for that formula. Again, we're at, 7 formulas total from 8.1 to 8.4. So you want to definitely keep track of that stuff before it gets to be too much. 2, write the expansion of the expression. So my n is 3, which means there's going to be 4 terms. I can either do C3, 0, C3, 1, C3, 2, and C3, 3. Or I can use Pascal's triangle, and that one is when it goes 1, 3. So those are also your binomial coefficients, which I think is obviously faster. Then you have to do your first term, highest exponent down to none. So I get 2x to the third, 2x to the second, 2x to the first, and 2x to the 0. And then you do the second term, which is negative 3y, and you're going to do that to 0 and build up. So negative 3y, 0, negative 3y to the first, negative 3y to the second, and negative 3y to the third. Now, you don't have to put the plus symbols in between if you remember that you're going to have to take the sign of whatever that coefficient is. But I have seen every year at least one person goes to multiply out consecutive terms. So be careful, okay? You should catch it because then there's not 4 terms. But for some reason, it happens. So for the first term, you're going to get 1 times 2x to the third, which would be 8x to the third. And then negative 3y to the 0 would just become 1. So this is 8x to the third. Second one, 3, 2x squared is 4x squared, and then negative 3y. Multiply out all your coefficients. So this is 12 times negative 3, that's negative 36. And the x squared y goes next. Then this is 3, 2x to the first, which stays as 2x. This would be 9y squared. Again, multiply out the numbers. So 6 times 9, that's 54, and it's positive. X to the first, y to the second, and then 1 times negative 27, y to the third, which is minus 27, y to the third. So there's your expanded binomial. So the question came up, what happens if you just expand it? Most likely it's not going to be raised to the third power, and it will be a huge waste of time. If you had extra time, when you see all the material put on this test, you probably won't, but if you had extra time, you could expand it, but I do expect to see that process. I don't care if you use Pascal's or the individual binomial coefficient formulas, but I do expect to see that process. All right, then 3, write the first 6 rows of Pascal's triangle. So it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. This is technically 1, 2, 3, 4, 5, 6 rows, okay? That is not the 6th row by name, though. So you can keep that. Like if you did the 6 rows, that's fine. But if it had asked for row 6, it would be the next row because this is technically row 0. So just be careful. This is when it's hard to jump directly to a row, okay? So I would say when you're doing something like 4 where you need to go directly to an individual term, I would think it's better to use your binomial coefficient formula. Yeah. Yeah, if you count them, there's 6 rows, but it wouldn't be the 6th row, okay? All right, so then 4 says find the 6th term of 3a plus b to the 7th. So this is our second formula from this section, and we need to do CNR, the first term to the n minus r, and the second term to the r. So our n is the exponent, and the r would be 1 less than the 6th term, so r is what? 5. Good. So C, 7, 5. First term 3a to the 7 minus 5, and second term b to the 5th. So C 7, 5 is 7 factorial over 2 factorial times 5 factorial. 7, 6, 5 factorial over 5 factorial, and then 2 times 1. These are gone. 2 goes into 6 3 times. So our binomial coefficient's 21. This would be 3a to the second, which is 9a squared, and b to the 5th. And then multiply your 21 times 9, and I get 189 a squared b to the 5th. So you definitely don't want to expand out something that is to the 7th power to find the 6th term. That would be a nightmare. You definitely need to know that formula. You wouldn't have time to do both. Questions on the warm-up. All right, so 8.5 is called Counting Principles. This is the foundation of where we'll get to with probability. So 8.6 is really probability, but this is going to be like just the foundation of it. So the foundation and be like starting with what you should already know about like probability, the basic kind of probability questions are called simple counting problems. And for these, if it said like, what's the probability of picking an even number from the set of 1 through 10? That's kind of what it would mean to be a simple counting problem. And so for these, you're going to put the number of what you're looking for over the number of the total items in the set. So if I was asking for the even numbers between 1 and 10, how many even numbers are between 1 and 10? So in between means between 1 and 10, right? It does not mean including 1 and 10. So how many are there? 4. 1, 2, 3, 4. There'd be 4 even numbers in between 1 and 10. And then we would put it over the total number of numbers there, right? Between 1 and 10, which is 8. And that would be 1 out of 2. So that's like a simple counting problem, right? This would be really basic. If you had a box full of different colored rocks and you wanted to pick a certain kind of rock, you would do the number of those rocks over the total number of rocks in the box. Yeah.
What would be like the wording for a table?
It would say inclusive. So if it says inclusive, it means including 1 and 10. Yeah, it will literally either say including 1 and 10, or it will say the word inclusive, and inclusive means it includes 1 and 10. Okay. Yep. All right, there are 2 types of questions here you got to pay attention to, and they are with replacement and without replacement. So the hardest part about when we get into probability and all that stuff is the verbiage for some people, like figuring out what it's actually asking for. And so you want to start to look for key terms, and they are with replacement. Well, the first of them are with replacement and without replacement. So a random selection from a fresh set each time is called with replacement. And a random selection that's removed after a choice is made is referred to as without replacement. So if I have, again, like let's say I have a box of candy and there's 10 different candy bars in there, and I ask somebody to come up, let's say I ask Jenna, come up and grab a piece of candy from that candy bin. What's the chances that that candy's chocolate? So we would figure out how many chocolate pieces are in there and divide it by the total number of pieces of candy. If she walks away with that candy, because it's COVID, she can't put it back. Nobody else can then have it, right? If she walks away with that candy, that would be without replacement. Now, what just happened is my box got limited 1 piece of candy, right? So that new probability is different. Now I'd have to recount how many pieces of chocolate are left and then how many pieces of total candy is left, okay? That's without replacement. If I just said come and grab it and then she puts it back in the box, that's with replacement. So you're starting with a fresh set every time. When you look at things like a random generated number from a computer, you assume that it's with replacement. So I assume that is a fresh set of numbers every time. Oh, good. Okay, great. Okay, thank you. So we assume that is randomly generated would be with replacement. If a computer is generating numbers, it doesn't take the number out, okay? So that's, if you roll a die, It's with replacement because it's the same die every time. It's not like one side of the die gets eliminated, right? But maybe if you're pulling from a deck of cards and you keep the card, that would be without replacement. So the set gets altered, okay? Those types of wording is important. And it may not be the word replacement. It might say puts it back or doesn't put it back, that kind of stuff. So example 1 says to determine the number of ways in which a computer can randomly generate one or more such integers or pairs of integers from 1 through 15. So randomly generated means that it's a fresh set, like every time it's that full set, okay? And it says randomly generate one or more integers or pairs of integers from 1 through 15. So how do I randomly generate numbers 1 through 15 is what you're looking for, okay? We're writing them all out. Hopefully we don't have to write them all out all the time. Like if you start to think about even numbers and that kind of stuff, it's going to be the same every time. But for this visual, we're going to draw them all out. So A says from this set of 15, how many ways can I pick an odd integer? So how many odd integers are there? There are 8. That's what it means by the number of ways it can pull an odd integer, okay? So there are 8. And notice the wording, it says from 1 through 15. That's how we know to include 1 and 15.
And we don't do it over 15?
It's not asking, so that's most of next section. For right now, we're just figuring out the number of combinations.
Oh,
Okay, so it just says the number of ways in which it can generate. If it then said what's the probability of picking an odd integer, that's when we would put the number of odd integers over the total. Yeah. All right, so B says an integer that's divisible by 4. So how many integers here are divisible by 4? Or what are they? 1, 2, 3. Good. So for right now, we're just counting the number of ways. The instruction says or pairs of integers because it also could have said like that 2 numbers that sum to something. That's what that means. All right, example 2 says 8 pieces of paper are numbered from 1 to 8 and placed in a box. One piece of paper, that's not once, one piece of paper is drawn from the box. Its number is written down and the piece of paper is returned to the box. Then a second piece of paper is drawn from the box. Its number is written down. Finally, the 2 numbers are added together. In how many different ways can the sum of 12 be obtained? So I italicized the words return to the box. Obviously, that means they're important. They will not be italicized on a quiz or test. So that's what you want to train yourself to look for things like that. What does it mean if it's returned to the box? With replacement. So it's returned to the box, which means you have a fresh set both times, okay? So the first number is going to get picked from 1, 2, 3, 4, 5, 6, 7, 8. And then whatever you pull that first time is going to get put back in the box. So the next time it's going to be pulled from 1, 2, 3, 4, 5, 6, 7, 8. The question is, the 2 numbers are added together in how many different ways can the sum of 12 be obtained? My recommendation is when you see sum, don't start with the smallest numbers. Go the other way, okay? Because if I do 1 plus 1 and 1 plus 2 and 1 plus 3 and 1 plus 4 and 1 plus 5 and 1 plus 6 and 1 plus 7 and 1 plus 8, none of them even equal 12. I've just wasted all of that time. If you work from the top down, when you get to 11, you know you're done. Does that make sense? So work backwards. So if I get an 8 the first time, and 8 plus 8, does that give me the sum of 12? No. 8, 7. 8, 6.
yes.
8, 6.
I'm sorry, I thought you were saying 6, 6.
No. 8, 5. No, 8, 4 is the first one that I can get. If it said, what are they, you have to list them. If they don't, you don't have to, but obviously it's easier to keep track if you're going to list them. So one option would be 8 the first time and 4 the second time. Then what if I pick a 7 the first time? Oh, no, sorry. Yeah, because that's it with 8. What would I pick the second time with 7 to get me 12? 7 and 5. What if I pick a 6 the first time? 6. If I pick the 5 the first time? 7. If I pick the 4 the first time? 8. If I pick the 3, can't happen. 2 can't happen. 1 can't happen, right? So there are 1, 2, 3, 4, 5 ways that the sum of 12 can be obtained. Okay, example 3, almost identical. It says 8 pieces of paper are drawn, numbers 1 through 8. 1 piece of paper is drawn from the box, numbers written down. This time it is not returned to the box. So how does that, it is without replacement. How does that affect what we just found? So if I had 8, 4, 7, 5, 6, 6, 5, 7, 4, 8. Is it the same option this time? Why not? If they're different numbers, it would still happen, right? So if I take out the 8, the 8's gone, but the 4 is still there, right? If I take out the 7, the 7's gone, but the 5's still there. But if I take out the 6 is not there for me to pull from the second time. Does that make sense? So that's the only option that can't happen this time. The 6 is gone. So now there are 4 ways for the sum of 12 to be obtained. So without replacement, you cannot pick the same thing twice because you didn't put it back. All right, the fundamental counting principle is talking about 2 separate events. So they use E1 and E2 as separate events, okay? The first, every year I forget to add the T in. The first event, E1, can occur M1 different ways. And then after E1 has occurred, E2 can occur M2 different ways. The number of ways 2 events can occur is M1 times M2. And what this means is whatever the first event is, let's say you roll a die. And you want something specific to happen, okay? And then, God bless you, you roll the die again. And you want something specific happen. The way you figure out the number of ways the both can happen, this is a both scenario, this and that, you literally multiply the number of ways the first thing can happen times the number of ways the second thing can happen. So if I said I wanted to pull a crayon from a box that has 5 different colors, okay? And I want to know what's the chances or how many different ways can I pull a color from the box the first time. If there's 5 different colors, there's 5 different ways to pull a color from that box, right? But then let's say I want to pull a color again the second time. If I've put it back, it is 5 times 5. That's how many different combinations there can be. If it's without replacement, now it's 5 times 4 because it is 1 less, okay? So if these are 2 separate events, you want to roll the die and flip a coin. You want to roll the die twice. Whatever the 2 separate events are, in order to find out the total number of ways it can be done, we multiply that number out. So eventually the and the or is going to get important here. This one we're saying and. So and means multiplication. All right, example 4. How many different pairs of letters from the English alphabet are possible? So here's what you don't want to do. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V. And then go A with B, A with C, A with D. And standardized tests love that stuff because it's a waste of time, right? So you just got to figure out the first letter. There's 2 letters. It's a pair of letters, right? How many letters can fill that first box?
37.
Oh, so close. I don't know if anybody ever gets it right the first time. 26. There are 26 letters in the alphabet. Every year it happens. I think it's on every video I've ever made.
I was like A, B, C. You did 37? Yeah. No, I lost count.
All right, so then it doesn't say anything about like there's a box of these letters. I've taken them out. I've kept them, right? Which means you're assuming it's a fresh set of the alphabet the next time. So how many, let's see if we can redeem ourselves. How many letters are there to pull from in the second one? 26. So in order to figure out how many pairs are possible, we literally just multiply these 2 numbers together. I love that you're still trying to justify. 6, let's try this, right? Again? Yeah, there we go. So there are 676 pairs of numbers that come out of the alphabet. Again, something you would not want to have to go A with A with B, A with C, A with D, A with, and then B through all of them.
And every year the person gets it.
All right, a combination lock will open the right choice of 3 numbers from 1 to 30 inclusive. So there's that word inclusive, which means what? Including 1 and 30, right? So if we are, how many different lock combinations are possible? So it has 3 numbers in it, For me, I want a visual of that 3 sequence. So 3 different numbers means 3 different digits go there. So how many the first time? How many number options are there from 1 to 30? 30. Did it say a number can't repeat? No, which means there are how many options the next time? 30. Which means there are how many options the next time? 30. Let's try that again. 3 times 3 times 3 is 27, and then 3 zeros. So there are 27,000 possibilities when you can pull from 30, 30, 30. All right, example 6. In a certain state, each license plate number consists of 2 letters followed by a 4-digit number. How many distinct license plate numbers can be formed? So again, for me, I like the setup of what the spaces are going to be. The first space is a letter. The second space is a letter. Then it's a 4-digit numbers, which means 4 separate 1-digit numbers. So how many letters can go in my first space? 26. How many letters can go in my second space? 26. How many numbers are 1 digit? 10. Why? 0 counts. 10, 10, 10, 10. So 26 times 26, we just did this. 676, and then 1, 2, 3, 4 zeros. All right, so again, you want to pay attention to wording like a digit cannot repeat or a letter cannot repeat, because then that changes the bank, okay? All right, a permutation is the number of ways n elements can be arranged. So the words are super important here. They should say something like arranged or put in order, okay? And what it means is you want to fill things in certain spots. So this is not the number of ways overall. This is arranged in a specific spot, okay? And the way we find a permutation is n factorial. The number of things you're setting up, factorial. So if it was 6, it's 6 times 5 times 4 times 3 times 1. So think about how this could be worded. Let's say day 1, I come in and there are exactly enough seats for the people in the classroom. And you guys all line up at the front of the classroom, right? And let's say there's 30 of you, okay? And let's say Michael's the first one through the door. And I say, Michael, choose a seat. How many seats does Michael have to choose from? 30, okay? Now Michael sits in that seat. And then I go, Anna, choose a seat. How many does she have to choose from? 29. And then Olivia would have? 28. And Gabby would have? 27. So you're forming your own factorial there. Does that make sense? The last person is only going to have 1 pick, which is where the factorial ends. But this is like pictures on a shelf, objects on a shelf. How many ways can they be arranged? They like things like, how many ways can you arrange people in a picture, okay? Whereas if they're in spot 1, that counts as 1. They can't be in spot 1 again, that kind of thing. So all of these are arranged in order. You want to look for words like that, and that means permutation, and permutation is factorials. So if it says how many ways can 10 objects be put in order, this would be 10 factorial. Which is, we're not going to multiply that out. Today's going to be rough. I literally typed 1 and then I rewrote the factorial. So 3,628,800 different ways 10 items can be put in order, which seems ridiculous, right? It's just 10 little items, okay? But that is a permutation. Example 7 says find the number of permutations of the following letters, A, B, C, D, E, F. So what you don't want to do is try to figure out how many different ways you can arrange that. That's when it gets really confusing. So you count how many there are, which is 6. And this answer would be 6 factorial. Or 720. All right, permutations of elements taken a specific amount at a time. So this says the number of permutations of n elements taken r at a time is given by, And this is similar to our C, right? It is P and R this time. So we use P for permutation. And the difference between this formula and C is that there's no R factorial at the end. So it's N factorial over N minus R factorial. So this means everybody's back up at the line at the front of the room, but I only want to fill 5 seats. I'm not filling all 30. So if you're taking from a group that is bigger than what you're filling or what you're arranging, and you want to arrange them a specific amount at a time, this is where P and R comes into play. So N is the total number of things in your set, so it would be 30 kids. R is how many I'm picking to fill those seats each time. So like 5 seats, 6 seats, whatever it is I'm filling, that's my R. You'll see things like this be like you're running in a race and there's 10 runners in this race. How many different ways can they finish first, second, and third? And that is a number of ways taken 3 at a time. If it is 10 or 10 running in the race and you want to know how they can finish all 10 of them, that's just 10 factorial. But if it's 10 and you're trying to fill like the first 3, first place, second place, third place, now it's P and R. 10 is your N and R is 3. All right, so this says find the number of permutations of 8 horses taken 3 at a time. So this is your P and R. The N is what? 8 horses. The R is 3 at a time. So this is P, 8, 3. 8 factorial over 8 minus 3 factorial. 8 factorial over 5 factorial. 8, 7, 6, 5 factorial over 5 factorial. 8 times 7 times 6, which is 336. So if it had just said 8 horses are running a race, how many different ways can they finish? That is 8 factorial. But this is saying specifically 3 at a time. And then P62, let's find on the calculator so you can practice, okay? So on a graphing utility, it's under probability, the same menu you used for the factorial and for C and R. On a scientific calculator, there's probably a PRB button or something like that, and that's where it would be. So if you have the newer TI, like this one, then you go straight to the menu. You go math, you scroll over to PROB, and you go to the second one in the line, which is NPR. And then it gives you the little subscripts to fill in. So I do 6, 2, I hit enter, and there's my answer, which is 30. On the older, can I borrow that?
Yes.
Thank you. On this one, you have to first put in your N. So I have to do 6 first, then I go math, then I scroll over to PRB, I go to NPR, and then I put the R. So you have to put the number in first, like it doesn't give you the little subscript, okay? Any scientific calculators you've got with you today that you don't know where it is? Here, let me find it for you. We're going to stop here for today. We'll pick up with distinguishable permutations tomorrow. Let me look at what number you can get to in the website. So where are we at? You can do 1 through 12, okay? I will tell you this about the probability. I don't want you to cheat on these because they are difficult to figure out what to do. That's the hardest part. So try each individual one. There is one, at least I think, that references a phone number, which you guys don't dial anymore. Wait, but let me figure out which one it is because they confuse it every year. So it's number 4. Let me scroll. 4 on the homework says, in 2010, a certain state had 2 area codes using information about telephone numbers given in example 4. How many telephone numbers could the state's phone system have accommodated? So this, I put this right on the assignment because you guys forget you have a book or can't, are lazy. But if you find your book and you go to example 4, it looks like this. And it basically says the telephone numbers in the United States have 10 digits. So if we include area code, there's 10 digits. The first are your area code, and then everything after that is the local number. It says that the first number cannot begin with a 0 or 1. Like, you can't start your area code with a 0 or a 1, and you can't start your within your area code with a 0 or 1. So this place can't be a 0 or 1, and this place can't be a 0 or 1. So if the question said within an area code how many combinations there are, I'd be doing just the local number part of this. 8 times 10 times 10 times 10 times 10. I lost my count of tens, but until you get to the end, okay? 8 because we've eliminated 0 and 1. So if it said within an area code, how many options are they? That's your answer, okay? But this question says that the state, this example, that number changes, but this one says it has 2 area codes. So if within an area code, it's 8 times 10 times 10 times 10 times 10 times 10 times 10, and then there are 2 options of those, you just have to multiply by 2. If it said there's 4 area codes, then that space gets filled with 4, okay? If it didn't tell you, then it would be 8 times 10 times 10 times 8 times 10 to all of that. So if it didn't give you an area code restriction, then it would be that full number, okay? But this question on the homework, so this one that's here says, that there are 2 area codes using the information, figure out how many. The within the area code is 8 times 10 times 10 times 10, 2, 3, 4. So within the area code, there are 8 million options, but then they're saying there's 2 area codes, which means there's 8 million twice, right? 8 million for the first option, 8 million for the second option. So this would be 16 million. If, like some of them say, there's 4 area codes, then you'd multiply it by 4. 5 area codes, and you multiply by 5. That one I feel like stumps everybody every year because we don't know how numbers work, like phone numbers. The hardest part is figuring out what to do where, I think, in these questions. So you can work on 1 through 12 today. If you get stuck on something tomorrow, you can always ask. We'll finish the notes tomorrow, and then that homework will be due Friday.